Hello everyone, welcome to my talk about Kerberos authentication updates in Samba 4.16, 4.17. My name is Stefan Metzmacher. I'm working for SerNet. I'm a member of the Samba-Team. And the topics today would be a reference to a Samba XP talk 2020, a few things regarding security updates related to Kerberos we had in the last months, testing improvements, some improvements in our KDC logic, a new updated Heimdal snapshot, and a few pending fixes which are almost ready and hopefully merged upstream soon, and then some outlook to the future and a few examples how you can reliably change a machine password without breaking it. So the first thing, I did talk at Samba XP 2020, which explained a lot of details of Kerberos on the packet layer and the interaction following cross-referral hooks and working in trusted domain environments. So if you're interested in that, you can have a look there. Then in November 2021, we fixed a lot of security problems related to Kerberos authentication, which were name-based races, a little bit similar to the symlink races, where people are able to create and rename usernames and then get different credentials based on that name change. There were an interesting talk from Andrew Bartlett at the Samba XP 2022, and that explained the details of that. So in general with Kerberos, so Samba is not only an SMB server, but also an Active Directory domain controller. So it's a KDC. And in order to get that logic right, we had to introduce some testing. Basically, we have a framework in Python where we can generate Kerberos tickets, just the raw packets, and can send anything we want in order to verify the KDC behaves in an expected way. So in 2020, I introduced that just with a simple test as some kind of proof of concept. And 2 years later, we are now expanded that to 21,000 lines of code with extreme corner cases and a lot of tests. There's still a lot of things we can improve there, but it's really much better than what we had before. And the important thing is that this is also catching regressions where before we were only able to accelerate the Kerberos libraries in order to do tests and weren't able to do all the corner cases which are important for Windows clients, for example. So currently Samba has an embedded Heimdal KDC, which is a default and has the most features, but there has been some work from Red Hat to replace that using the MIT Kerberos KDC. And basically in 4.16, they improved the situation and re-added some features which were already there in Heimdal. And yeah, that's the pkinit, SVU to self, SVU to proxy stuff that was added there. So we still have this as experimental, but with the MIT 120 release, there have been a lot of improvements, and the Python testing is able to show that it's not so dangerous to do the switch to the other DC. So in 4.15, we basically had the same snapshot of Heimdal we had in 2011. We only fixed important bugs there, but basically upstream Heimdal and our code diverged quite a bit. And with 4.16, we imported a fresh snapshot from Heimdal, rebased our patches, and created merge requests for upstream Heimdal in order to get some of this upstream, but we still have a few patches there. But this is an improvement to what we had before. And it also means the internal Heimdal APIs are much richer in order to implement features we need to emulate the Active Directory KDC. So what this brings is a feature called Kerberos FAST. This is basically something that allows Kerberos request armoring. So, for example, when you log into a Windows workstation and enter your weak password, then this will be encrypted with the Kerberos ticket from the machine. So, and as machine passwords are very strong, you no longer send the weakly encrypted Kerberos request to the KDC in plain text. And what this also brings is that the resulting Kerberos pack would contain information on which workstation you're logged in. So that the access decisions made on, for example, a file server are much more rich and allow you to, for example, say you can't access that file if you're coming from your laptop, but you're allowed when you're coming from your workstation in the company. So with Heimdal and MIT, this is now used by default, but in Samba we only actively use it at the client for the Kerberos service ticket request, the TGS request. There's a bit more work needed to do the authentication with PAM Winbind or so in order to protect that. Windows clients don't use FAST by default, but there's a GPO setting you need to set, and also you need to announce as a Windows 2012 DC, and we're not doing that, so Windows clients don't use FAST by default now. So there were some outstanding important fixes I was working on in the last years, which were present in the old Heimdal code, and with the new import I was able to fix them a bit easier. So what we had previously was when a client mounts a share with Kerberos, it has a ticket, everything is fine. Then after 10 hours the ticket is expired. The SMB server sends network session expired, and the client retries with the original password that was given at mount time. And if the user changed the password in between, automated mounts with the old password would immediately log out the account just because the password was changed and the old one was used. And I was able to fix that. So for NTLM, we already had that fixed, that when the client comes with a password in the password history, I think the last 3 passwords are analyzed, and if a client comes with that, they still get access denied, but the bad password counter wouldn't be increased. So the account is no longer logged out just because the stale password of the mount binary. So the next thing was the S4U2 proxy support for Windows clients. And there were a few bugs there where we didn't handle requests correctly, didn't have the correct time in the pack, and so on. And that was also fixed now. So we have merge requests for both, so I just need to do some preparation in order to get that upstream, but the code is more or less functional and working. The third thing is that Windows announces the supported encryption types in the pack and in communication with the KDC. We are now doing the same in order to let the client know that it can use stronger encryption types by default. So for the future, what we could implement using the new KDC APIs in Heimdal is the so-called claims support. That's basically what I said before, where you have the compound identity and then have, in addition to that, so-called claims, where you can somehow define these things like you're allowed from that machine but not from the others, and all kind of things there. And with this new APIs, it should be very easy to implement that without needing to change the core Heimdal code. Also, as mentioned, for the WinBind case, with PAM WinBind, we would be able to accelerate the FAST mechanism in order to prevent sending weak passwords or blobs encrypted with weak passwords on the wire. So, one example from a long road to get the code that changes the machine password reliable. So, when Samba is a member of a domain as the file server, we have WinBind in order to do the work of the domain join, forwarding, NTLM authentication, and so on. And that also periodically changes the machine password every week. And it turns out that it's not trivial to change the password against Windows domain controllers and still generate a very random password. So initially I tried passwords with any random UTF-8 characters up to 255, and did almost everything random. And as a result, we got reports that machines get kicked out of the domain. And the problem was some had the Unix char set option set in smb.conf saying we are just using some, maybe char set like ISO 88591 or so. So not UTF-8, which is the default. And the problem was when we converted the password using that char set, the password was no longer compatible with the Heimdal and MIT libraries. And they don't support compounded UTF-16 characters. So we had a problem there. Once we fixed it, we reduced the character set to just 16-bit. So we avoided the compound UTF-16 characters. And if we find invalid characters, for example, when the Unix char set is not UTF-8, we fall back to random ASCII characters. And with that strategy, we do some double checking, converting back and forth between the UTF-16 password and the ASCII and Unix char set and UTF-8, and only if they all match, we are going to use that password and send it to the server. So currently we do try to store the new password first. So in the past we had problems where we first changed the password on the server, and then in a clustered environment with CTDB we were not able to store the password in secret CDB because of a temporary problem, and that meant that the server had the new password, but we were not able to store it and were kicked out of the domain, basically. And in order to mitigate that, we now store the change password as next change first and maintain 3 and 4 generations of password. The current one, old and older. And before we try a remote change, we store the one we will use for the next change. And that is persisted before we even start. And if we then later retry, we will retry with that one until it gets success. And we also need to consider that the server already knows about the next change, because it could be that we did the remote change and we didn't get the response, or the server didn't get the request. So we need to catch both cases. So we try and see if the server knows about the next change, then we just store it. Otherwise, we do the remote change and try to store the result. Even if it fails, we also remember the failure and so on in order to debug things and remember the server we did the change to. So, and even with that, we still had problems as some customers reported problems that their members get kicked out of the domain, and it turns out they did change the password against the read-only DC. And in theory, the read-only DC should just forward the request to the read-write DC with the netlogon send to SAM request. But it turns out that if the read-write DC returns an error, invalid parameter, because the password is longer as 127 characters, the read-only DC still reports okay, success to the client. So when we get success from the read-only DC, we just store the new password, and in some situations we are then kicked out of the domain because we now have the password stored, but no server got it yet. So, and it turns out that because we did the randomizing password lengths, sometimes we hit that problem and sometimes don't. So now we finally match windows and just use fixed size 120 character passwords, and the password change works against read-only DCs reliable now. So this is just an example to show how important it is that we almost closely as possible match what Windows is doing. And we had a lot of similar cases like that in the last 20 years working in that environment. Because otherwise, if you don't do exactly like a Windows server, which is the reference implementation, either you trigger untested code paths in Windows itself, or other vendors only test against Windows and expect that behavior exactly, and it's just causing trouble if we try to be smart and use other things.
Is Microsoft aware of this problem?
I'm not sure. I think I sent it, but I would need to double check. Yes. With that, I'm done with my talk. Any questions? Steve?
One of the things you touched on briefly was the private data area in the Kerberos FAST. You briefly talked about claims. And
Yes. Yes.
So one of the things I never understood very well was exactly how those claims are verified and how that works. But it brought up the question of if you support the claims of the Kerberos FAST, is there a way to store claims-based apples in Samba so you could enforce those claims?
So the question is, if our KDC would support claims in the Kerberos database, would then Samba be support evaluating the claims? And the answer is no, because we don't know very much about claims yet. So the first thing would be to analyze how this works, and some Samba-Team member from Catalyst, Joseph Sultan or something like that, I'm not remember his last name correctly. He recently added some tests using this Python-based Kerberos testing in order to evaluate how claims are supposed to work. But that is the first step, and when we have that, then we can do some research on how this affects the file servers and the actual evaluation there.
Very exciting.
Okay, thank you very much.